afternoon, everyone, and welcome on behalf of the select group to the next in our technical webinar series. We are excited to have you with us and also to have JG Perrin back with us today talking about enterprise software. JG is very well known to many of you across the AI community, and I know has got some exciting things planned for us today. A couple of housekeeping items on behalf of us. Please keep your lines muted until we get to a Q&A at the end. Also, you will be receiving a recording of this webinar after it takes place, as well as a brief survey. We would love to hear from you on any additional topics that you'd like to hear about, or if one of you has something that you would like to share with the community as well. On behalf of the Experience team, we hope you enjoy. And JG, I'm going to turn things over to you.
Okay. I hope the sound is kind of okay. So,
yep,
okay.
I can see you, hear you, and see your screen. So you are good to go.
Yeah, good. Okay. So welcome to this talk. We're going to talk about building enterprise software, and I added today because I liked that the acronym was making it a little bit better. So before we get started, I'm going to just introduce myself quickly. So my name is Jean-Georges Perrin. So some people call me Jean-Georges, like my wife, my mom, and a lot of people also call me JG because it's much easier to pronounce. I've been doing software as a professional since 1995, and I took a quick stab, a serious stab at big data and AI, and now I'm looking at things a little bit more holistically, and we'll know why. I'll talk a little bit more about that. I've been a safe architect for a short time now, and also a practitioner of both system design and safe for some time now. One thing that makes me particularly proud is that I've been an IBM champion for 13 years and running. And this has been renewed like a week ago or so. You may have heard of me on this air before, and where I was talking about Spark as I was writing as I wrote the book about Spark. And to be honest, in a very fair way, it's the best book on Spark. That's what Amazon says. Okay, so when you look at the ratings. So when I'm not giving talks or writing books, my main activity is being an enterprise architect for Advanced Auto Parts, and as part of the digital garage, our digital transformation as well. So, okay, that's it about me. There's a word of caution. So this content is really new. This is something I had in my mind for a while, and it was great from the select group to let me experiment with this content on you guys. You're a bit of guinea pigs here. It's describing an approach to software engineering and architecting. It's possible that I missed a few things there, and I would be really honored and flattered if you could give me feedbacks via Twitter at JG Perrin. So that's a word of warning. Okay, so it looks like nobody left yet, so I assume that you're still interested. So I don't know if you guys know anything about Ayurveda. Ayurveda is this ancient, well, it's still in use, of course, but it started a very long time ago, ancient Indian medicine, okay, like a bit like a parallel and a predecessor to Chinese medicine, which is a bit more known. The idea is to have an holistic view of the medicine of your body and mind. And I think this is something that was missing in software. And this holistic view, this is what I tried to capture in this talk. And hopefully I didn't miss too much. So I like to to come back with a history a little bit before. I'm a strong believer that in order to understand where we are, we need to look at the past. Of course, it's applicable to the world, as Martin Luther King Jr. was saying, or in software engineering. Okay, so and I'm pretty sure that what MLK had in mind when he said we are not makers of history, we are made by history. The we was people, but if you translate that to enterprise systems, you could say something like enterprise systems are made by history. Okay, and this is also something we will talk more. So when we look a little bit back, I think it all started by black magic. Okay, we never knew really how it started, so that's a good supposition. You had spec writers, okay, because they knew better, right? They knew how to write stuff and describe things. You had project managers. Well, we didn't need to Scrum, okay? We need Gantt at that time, and you had that database administrator because they were just administrating database because that's where we store data. You had system administrators, which were, yeah, just managing the systems and making it. And of course, you had developers who are producing code. This was, for me, a very compartmentalized vision of software. So yeah, it started by the spec writers. They know the business, okay, and they discuss with managers, and managers started to, at that point, managers were a little bit architect as well, and they were designing the software, and then they were talking to the database administrators, and from the database administrators you get a schema, an ERD schema, and the developers would start writing code from it. And finally, when you were ready for deployment, you would talk to your system administrator and say, hey, here's my code, please make sure that it runs on your production system. So you had this idea of, five-ish group of people working together and in a process, and this process was really about creating this gated process. Okay, so I start by writing my spec, then I give it to the project manager slash architect, then I'm giving it um, to the DBAs, then I'm giving it to the coders, then I'm deploying it. And this gated process, when was working, would have a certain duration. However, as you can imagine, or as you experienced it, it was not perfect. Okay, so something like, five, something that was planned for 5 periods would easily go back to 7 because you miss a gate, or and something was wrong, so you had to go back. Okay, and so that was one of the problem. Another problem was it scales poorly. So as you had many teams, okay, what something you could imagine that was going on a regular cadence was actually completely off track. Okay, and if you see here, my purple team was, yeah, almost on time all the time. My orange team was late at the beginning quite a bit and delayed everybody else, where my blue team was always on time except for the last one. Okay, and you can imagine that at who would be blamed is definitely the blue team because they could not deliver the software on time. But the cadence on this gated phase forced everybody to get a bit aligned. So, and there was also some demand for more control. So something like, oh, this 5 gate process, okay, could easily become more as the evolution of software became obvious. You need more UX people creating this user experience we all need in software, which was something that was not really thought of before. And I place it here in the design, but it's often came later and after even the database design, so that created even more trouble. Of course, we all are more conscious and more demanding on infosec, okay, and security around our processes. So you had to add several gates in your process, and I just added 2 here for what could be gates for security after you design your application and before you deploy your application. And we know that that doesn't work because we need more security. So that was kind of the constraint. And then everything was really also very database centric. Okay, so forgive me if this is something that looks obvious to you, but I'm going to look a little bit about why we started designing database centric system. Okay, I took a receipt here from your best auto parts store in town, and I'm going to cut it down a little bit. Okay, so first, you could look at what the receipt itself was, and you can see that you've got a date, you've got a transaction ID, you've got a time, you've got a payment type, etc. Okay, so that's some of the information there you get from this ticket. You also have, of course, a detail of your receipt. Okay, so you see that I was big on washer fluid this time, and you see the coupons that can be associated to your transaction as well. Okay, there was a special on washer fluid, so buy one get one at 50% off. So that's why I've got these two different price on the discount and in the screen you can see. And as I'm a team member, I got a special discount as well. So that's one of the perks we get as being employees. And of course, as you can see the details on the receipt itself here, you can also think about the store. Okay, so we've got 6,000 stores roughly. So all our stores have some special properties are going to be printed on the receipt. Okay, so that's kind of a very simple way, and you can say, oh, okay, we put everything together, and as we put everything together, we can finally put some relations, and that's why we created this relation database. Okay, enough of a refresher on the third normal form. So, but what changed? Okay, and why did you get a refresher on the third normal form in relational database system? Well, so web came along and we have this huge need for instantness. Everything needs to be instant, immediate, like right now. And so this drove the industry, our industry, in a different way. So first, I'd like to say that I love you, and the refresher on the relational database is just to make sure that you still understand that relational databases are still relevant in 2021. Okay, I don't want you to end up like this poor guy in South Carolina, actually, that was hospitalized after discovering all the good things about PostgreSQL and building his career on NoSQL. Okay, well, that was sarcasm, of course. So what I mean by that is even if things have changed, you still can build, and you're building on your existing foundations. This is one of the critical parts in your career. Okay, so you don't have to unlearn things, except maybe a few things if you're coming from a waterfall background. But all this relevant knowledge is actually bringing you and accelerating you into this into further into further development of your career. But what really changed is this idea of customer experience. Okay, so this is something that is driving the market right now. So you're not focusing anymore on the database, okay, and you're not your development strategy when you're building software is not database oriented anymore, but it's customer oriented, because you're trying to build this this great customer experience. And one of the things to start doing is to understanding your personas. So personas are fictitious characters that represents the different roles that are going to be using your applications. So here Advanced Autopart started an open source program recently, and we released an ETL tool called Data in the Fast Lane. And to build data in the fast lane, we had a reflection about who is going to be using this tool. So we're having Sonia as a data scientist, we've got Shelly as a data engineer, and we've got Eric as the DevOps engineer. And they have different needs. And as we were building the software, we were thinking and keeping in mind and creating user stories about these different personas. This exercise is really called design thinking. You're thinking about the design. One tool that can be used for doing that is the empathy map, and this is a great tool where you can collect information about your prospective users and prospective consumers. Okay, consumers doesn't have to be B2C in a store. It can be, well, for us, it could be in a mechanical shop, or it could be internal customers as well. As, for example, I'm working a lot with marketing these days. So it's really about who are we empathizing with, what do they need to do, what do they see, what do they say, what do they do, what do they hear, how do they feel, how do they think about all that. Okay, so this is a great tool for trying to understand your customer. This is not a technical tool that a software engineer will do alone, but a software engineer or the architect takes this tool and start and take it forward with the product owner, with the consumer himself, etc. So, and then one important thing also, we're in 2021, okay? So everybody's been doing some project. So even if someone here tells you, hey, I've got this incredible website to build and it's from scratch, you're completely free of using what you want, and et cetera, et cetera. And you've got to be careful about that, okay? Projects from scratch do not really exist anymore, because you're starting your website, let's say an e-commerce website, okay? And then you add an interface to a CRM, you add an interface to a recommendation engine, and you can also for example, have an interface to a loyalty engine, okay, to drive more customers. So this is where those one way, and the most obvious way to interface with the systems, is via what we call microservices, which are using APIs. They exchange between the website and, let's say, the loyalty engineer. They exchange predefined payloads, and they also share endpoints so they know what they're talking about. So this is really what we call integration. Okay, and integration is not the exception anymore. A few years ago, integration was probably not as popular as it is now, but is or as needed as it is now. But this is really the bread and butter of anything we're doing now. So at first it may look a little bit complex, okay? Oh, why do I have to add this integration layer, which I materialized here as an API gateway? Well, the thing is, it had a lot of benefits. Among them, it allows you to loosely couple your application. So if you want to change one, it's going to make it easier. It also makes it gives you the availability for you to monitor the health of your microservices, of the services outside. Some of them may be outside of your realm. Okay, you can monitor and control the usage, and by that you can also add security. So now, if I want to replace one component, like I say, I'd like to replace my old loyalty engine, well, now I can have my super duper loyalty engine that rules everything. And what do I need to change between the two? Well, only at the API gateway level, I can just change a payload, and that's it. It's make my integration with a new component that fulfills better need for myself, or a better experience for my customers, in a faster and a better way. As we want to keep it loose, and I would say as an extension to the microservices, you can think about another model, another pattern, which is called the event stream model. So basically, in this scenario, you've got applications that are generating data. As you saw in the previous example with the microservices, it's a very transactional oriented stuff. Okay, you've got the consumer of the service. In our previous case, it's a web service that is starting a transaction with one of the service. Here, you've got the application that is generating the data, and it posts the data into a topic. And this topic can be consumed by applications. The applications, they don't need to know each other about anything about them, okay? And they don't even need to know about the applications that is generating the data. We only have to agree once more on the payload that is being exchanged between the different applications. So as an example, imagine a point of sale system, okay, where you're going to a store, buying your favorite auto parts, and you're buying all these parts. You go to the register, you pay, and you are being sent via email and a receipt, your receipt. You can have an e-receipt, okay? So it's not, it's definitely not the point of sale that is going to open the mail in Outlook and send you the mail, right? You got that. But, and it's not even the point of sale system that is going to be connected to the mail. It's an application that is going to listen on something happening, and they're going to take this message, this payload, and send you the mail. And exactly the same feeling, you can imagine that if I want to add your loyalty points to your system, well, I would listen to the same topic and say, oh, Joe got this, and I'm going to add him this wonderful 500 speed perks points, so he can benefit from the loyalty he proved to the company. So and you can imagine that, yeah, an email system and a loyalty system, they don't talk to one another. They don't have to talk to one another. Okay. Eventually the loyalty system can send something, but some emails, but it's not directly loyal. So this allows you to build architectures that are more flexible, that are more real time. I'm not saying more near real time. And one of the additional benefit of that is that you can say goodbye to nightly batches, okay? Because nightly batches take time, they fail, they create some backlog, and they're pretty expensive to maintain. So as you go into this new kind of architecture, you will be confronted to technical debt. And I'd like to categorize technical debt in two ways: the historical technical debt. Okay, this is based on the decisions that have occurred in the past and the obsolescence eventually that are not interested anymore. Okay, so let's say you decided to use Oracle 20 years ago, and you stop paying for support after 5 years. Well, this is an example of decision in the past that conducted to obsolescence and is part of a technical debt. Sometimes, however, you've got less obvious technical debt that is made of conscious decisions. And this is because you want to control the scope of your project. You may imagine that at some point I wanted to get more information about something, or I wanted to add this feature to my application, but that will create a scope creep, and I don't want my project to derail. Okay, so to avoid that, I can decide that I can decide that that the I can limit my creep, okay, my scope, and it will be a technical debt, and just stop it. Okay, stop there, and recognize that it's a bad decision, in an absolute way, but in the context of this project, to limit scope creep or to control cost, I decide to make a technical debt decision. So it's not always bad, but it is extremely bad if you don't document it and don't keep track of it. Okay, you've got to make sure that if you make such a decisions, you can revisit them or you understand why it happened before. Another key change in history was how deployment, or just the idea of distributing your work or your application, has changed. It you know, back in the days, you had floppy disks you installed from 8 inches to 3.5 inches, and the idea at that time was to go through a very formal process. Not saying that it's not formal anymore, but at the end of the application. Okay, and I'd like to take this. I like this example of Microsoft Visual Basic, because this is one of the languages I started professionally working back in the 90s, and back there in 93. So distributing your application, which was not even calling deployment, it was distributing, was covered in the 25th chapter out of 25 chapters in the book. Okay, where of course I'm promoting my book here, really shameless plug. But more recently, in Spark in Action, I wanted to start the deployment of the application in chapter 5, and the actual deployment with all the technique for deploying it was in chapter 6 out of 17 chapters. Okay, so it's really early on. And this willingness to release early and frequently was one of the one of the consequences of the DevOps practice. So, talking about DevOps, where does it come from? Okay, I think my understanding is that really it comes from this very new idea from 1959 from Mizuno-san from the Tokyo Institute of Technology, that that defines the PDCA cycle. Okay, so you plan, you do, you check, you act, and you start over. Plan, do, check, act. Okay, so this is, and for me, when we go to DevOps, it's really about exactly the same thing at a faster pace. Okay, as fast as a sprint, as fast as a day, to be able to release really quickly. Okay, so you've got you plan, you code, you build, you test, you release, you deploy, you operate, you monitor, you plan, you code, and I'm losing my breath. But this is really the idea there, and I'd like to extend that to the scalable agile framework, where you've got this definition around DevOps, which are really calmer. Okay, so that's how they do it. They define it. Where the C stands for really a culture of shared responsibility. It's not a boss dictating you. It's a leader eventually, and a group of a community of leaders that is actually sharing the responsibility. And this is about collaboration, this is about organization, this is about risk tolerance and people tolerance. It's about self-serving infrastructure. It's about sharing knowledge, something which is really important to my heart. And it's about having this mindset of automating everything, which is automate everything. It's pretty obvious, right? And then you've got this L, this lean flow, where you visualize and limit your work in progress. Okay, you don't want to have huge amount of work in progress, only small batches of work, all small stories. It's always better to have 2 or 3 point stories and a big 13-point stories in your sprint. And I recognize that I'm not defining a story. Okay, but and the M Okay, it's measure everything. And it's really about log, not only, but logs are becoming your best friend. Okay. And you measure everything, you keep track of everything, you log everything. And the best thing of that is you can use Spark to run analytics on your new collected data. And finally, the R is the recovery. Okay, it's about you deploy, but you can go back. You can roll back quickly, or you can fix forward your application. So that's really this culture of not fire and forget, but this culture of being responsible collectively. To enable that, there is something that is called infrastructure as code. In a classic way, you would say something like, hey, give me two application servers and give me a database servers and give me this rate feature for this application server. And then you would start procuring this thing. So you can see in this example, you could definitely see IBM and ask for nice X series, and they will be happy to do that. Now you've got to see Lenovo for X series, but and it's still a way to do it, and you may still have to do it in some ways. But when you're thinking about the cloud way, you will start with a Docker file and say, and your Docker file will define what you want to do and what the system is going to behave. Okay. And you can still see IBM because they'd love to sell you IBM Cloud. So, and this is where it's IT is once more confronted to accounting. Okay. So it's always the same debate between CAPEX, which is capital expenditure, versus OPEX, which is operational expenditure. When you buy your hardware, let's say I've got 100K of hardware for my project, then I've got to mobilize CAPEX, okay? I've got to pay this money. And this money will have to have some depreciation over 5 years. So the fiscal benefit of buying something will only be visible over a period of 5 years. Whereas when I'm spending money with OPEX, my money is the fiscal benefit of spending money is seen right away. Of course, companies don't like to spend money, but they have to. Okay, and that's really something that is also getting a big favor in favor of OPEX. So, what does that mean actually? Infrastructure as code. It's really about defining your needs. I'm taking a file, YAML, JSON, whatever, and I'm starting to define my infrastructure. Let's say I want a load balancer, I want my application servers, I want my database cluster, and all that I'm writing that in a file, and then I'm giving it to this infrastructure. This infrastructure as code tool that is going to transform my desires, my wildest desires, into physical or almost physical solutions. Okay, and this is tools like CloudFormation on AWS or Terraform that is available a bit wider, will help you do that. And it creates the environment, and it also creates the links between your servers. Okay, so all this network as code is also defined there. So I know that my load balancers know about my two application servers here, that my application servers know about my database, and I can also use this um, this infrastructure as code to define my passwords. Okay, so I can say, and I'm defining rules about my passwords. I'm not putting my password in clear in the text there in text files, but I'm defining rules, and I so that my database server knows about the application servers and naturally goes further. In this diagram, you see these little green clouds. The thing is, whether I need specific stuff like my application server, let's say I want to use Web3 application server, then I can use my custom rollout applications I want, or I can use cloud resources like here my load balancer, my database, which could be RDS or Postgres on the cloud, or I could use Confluent Kafka for my event streaming there. Okay, so that this I could mix specific needs real stuff I really need from my side, and leverage as well resources that are made available by the cloud provider. And there's no limit. Okay, the thing is, okay, I have my development environment, and then all of a sudden I can have my QA environment, and I can have my production environment based on the same file. Okay, and if I've got a really complex organization, I can even imagine having a fourth environment or a fifth. Okay, and all that based out of almost copy paste from my infrastructure document. One of the great things as well about that is that I can have different versions of this infrastructure. So I can have my V1, my V2, and my V3, and I can roll back. Okay, and here you see that my current one is my V3, and this is I'm sorry, and this is source controllable. Okay, so I can add that to my source control. Okay, so this is yeah, sorry. So it could be in GitHub as well. So I can go back and have branches and all those things. So this innovation has been made available by the cloud and by a specific version of the cloud. So let's go a little bit in history there. Okay, in the 70s, software was almost free. You buy the hardware, you get the software with it. In the 80s, you see the rise of the license. People like Oracle coming there, Informix, and Lotus, and all these people that are starting to sell software to you based on a license scheme. And in the 90s, open source came. Okay, so the Linux kernel was released in September 91, and it matures over time up to a point where company says, "Hey, I want open source. I don't want to pay for licenses anymore," and this is combined a bit with the rise of the internet in the 2000 with Google's IPO was in 2004, and at that point the rise of the internet combined to the development of open source there's a direct correlation there, made it an interesting market for the cloud to come. And this is really, like I would say, in the late 2000s, early 2010s, that the cloud was really taking some growth. AWS was created in 2006, but Amazon.com was only fully migrated in 2010. SoftLayer was created before, but it was acquired by IBM and became IBM Cloud in 2013. A few names in between. The first version of Azure was released in February 2010. So it's really the 2010s that started to create this vision of the cloud. And the companies love that because it's only OPEX. Okay, if you remember from before, there's no CAPEX, there's OPEX here. And a lot of these companies were offering open source free software via these platforms. Okay, and it was also interesting to note that it was open source. Open source was also complex because you've got to recompile, who's maintaining it, all the so companies like Red Hat came there, and when you combine this attitude with the cloud, this is where you see that there's really a match where I can combine my support for my open source with my infrastructure and do that with the cloud. And but as you recreated a longer a vendor dependency, okay, and enterprises see that didn't like that, and as much as they didn't want to pay for licenses and they didn't want to be locked down to a vendor, well, same thing happened with the cloud, where companies don't want to be locked down. Okay, so they don't like to depend on one supplier, so. And with no possible interchangeability. So that's why in the 2015s or so, there was a rise of a more open cloud, okay? And this is where you start up seeing things like Dockers in 2013 appearing. The initial release of Kubernetes appeared in 2014, and even OpenShift was created before. But when you think about Red Hat, which is embedded and built on top of Docker and Kubernetes, it was released in 2015. So the version 3, which is a major step forward for OpenShift. So it's really, when you look at the cloud, what is really important is you've got the providers, okay, AWS, Azure, IBM Cloud, Google Cloud Platform, or OVH Cloud, or many others. You've got also Alibaba, Oracle. So you've got your infrastructure provider. And you have now an open standard on which you can build your application in a more reliable way, where you can have Docker, okay, where defining your machine, you can have everything orchestrated by Kubernetes, and even things like functions, okay. So if you're into Lambda function or Azure functions or IBM functions, you can use the same thing with now things called Knative, which is part of this Kubernetes ecosystem. And all that, if you don't want to spend hours working on administrating Kubernetes, you can have things like OpenShift that can help you do a little bit of this, a little bit more, simplify a little bit this architecture. So this is where the cloud is becoming this new, even this nicer boost of openness. I need to talk about documentation. This is a nightmare for a lot of teams and a nightmare for a lot of projects. And I don't remember a project where I was happy with the documentation. And I'm not saying that the project I'm on have good documentation, but there's an easy way of avoiding the documentation nightmare. First, making sure that your documentation is alive, okay? You may be aware that us as US taxpayers, we are financing this new aircraft, this new Air Force One. Okay, it's going to be it's going to come to an airport near you in 2025. But the documentation for this aircraft costs $84 million, and it's more than 100,000 pages. This is not the kind of documentation I'm speaking about. Documentation is there to build efficient engineering teams. It's not about copy pasting things you find on the internet and putting on your internal wiki. It's a living organism. It's living with the team. And over time, I've created based on, I've adapted this pyramid of views, which I think is covering all aspects of the technical documentation. As you see, the first one at the bottom, it reads from, like the pyramid of Maslow's, it reads from the bottom to the top. It's really starting with a wider audience until really an operational audience, which is usually not the biggest audience in your project. So it starts with a context viewpoint, which describes the relationships and the dependencies between your systems, okay, and between the environment, which is the people, systems, external entities, etc. It's a very high-level view, and it's really about system thinking. The next step is a functional view, which is describing the runtime of each element. Okay, so that's a little bit more the responsibility of each component, their interface, their primary interactions. That's that level of things. And then you define the information viewpoint, which is really data. It can be database, system stores, how you manipulate the data, how you distribute it, etc. But this is usually where I put my ERD diagrams there. Then you've got the concurrency. Depending on your project, you may just skip it, but it's really interesting to understand a little bit what's going on and what's concurrent in your system, especially when you design real-time systems or where concurrency is really important. Finally, you've got your development documentation, okay, what the developer needs to know, how was the nodes they take during the project, and then the next step is deployment, okay, how do you deploy, which is coming back to the CI/CD before, as we are deploying as we develop. And this documentation is here. And finally, you've got your operational document is, hey, when I'm giving it to the pure ops people, please read this documentation about how this is structured. So when you've got the 7 viewpoints, it makes things a little bit easier than to have this humongous data that you've got to put in structure. Okay, so that's one kind of guidelines I'm following. And of course, we could have a full session on really implementing this methodology. I'd like also to spend a little bit of time on security. Security has not always been the priority on project. And if you remember my previous diagram, I kind of had security gates, and they would just look the previous gates worth of work, okay, and it's really not enough. It's really you've got to implement really security as a culture, and this means that you've got to change the way you work, and this is where you start, not only because of security, but because of all this numerous numbers of actors, that you've got to make a way to scale this work process. And this is where I like to use a methodology called SAFe, which stands for Scalable Agile Framework. And I've been lucky enough to see that scale in several of my lifetimes, and this is really where you can see how you can apply agile and get the framework. And it's a framework, you don't have to take it all, but you've got all the tools to make sure that you can build your successful teams from sprint over sprint, combined in program increments that enables you to sync with the different elements in the company. So yeah, agile, and more precisely, SAFe. So I think it's about time to conclude already. And as we're going through all this content pretty fast, but the first conclusion is just don't bother. Listen to people near me that just said, don't bother, just go to Stack Overflow and copy paste everything, right? Well, not really, would I say. But anyway, I'd like to compare the then and now situation. In the past, I would say we had some kind of predictable loads, okay? And now we have to think about scalable architectures. Everything was database centric, but now we're focusing a lot more on the customer. We want to give him a good experience, not only seeing IT as a transaction-based system. In the past, a lot of things were processed as batches, and now we need real time. IT was really based on a need, okay? We had to do something, but now it's all ubiquitous. You've got your phone, you've got your iPad, you've got your computer. You don't leave home without a computer on you. And before, we also were really hardware dependent, and the cloud has kind of made us a little bit independent for that. And where security was merely a concern before, we've got to embrace security as a culture. With all that, thank you very much. And let's open it for questions. So I've seen a few questions or comments in the chat. So yeah, log files are made of history, and log files are real important, especially in the DevOps way of thinking as well, where you've got to measure everything and keep track of everything. So log files are precious, and they need to be analyzed and kept and archived. So for sure. I'm probably not going to share the slides. I'm okay to share the recording, and it's going to be also on YouTube. Yeah. So, other comments, questions? Are you going to buy your parts at Auto Parts now? At Advanced Auto Parts?
Either that or AutoZone.
Well, then we are not friends anymore. um, yeah, well, so one of the question is, what are the pitfalls of not providing proper documentation? And there's first is, what is proper documentation? Proper documentation means also that it's relevant documentation. It's documentation that is matching your system, okay? And that's why it's a living organism. It's not like you do the documentation and then you code and then you've got discrepancies, but it's really about matching the documentation and the right level. And if you don't have it, well, I've seen that on several projects. The first phase of the evolution or the maintenance of your project is going to be about reverse engineering and reverse documenting your project. And this might be a very complex task because you don't know what people had in mind. You don't know what people were thinking. You don't know what resulted in these decisions. And sometimes you even have to go back to the source code. And sometimes you don't have the source code because it's only compiled code. So documentation is really critical. And it doesn't have to be tons and tons of documents, but a few diagrams explaining the flows, explaining who were the stakeholders, explaining what was in mind, some of the decisions being made on the project. This is really important. Can you talk about a couple of trends which did not succeed, or at least never became as popular or pervasive as anticipated, and speculate why not? Oof. Victor, I'm not getting your question. In terms of methodology, would you like to unmute and we can talk about your question? I don't know if you're able to unmute. I jump to Kevin's question. Do you start with a vision and strategy document before you start a project? Actually, that's a very good question. Usually, yes, I do. I do, but it's not me because it depends on the role on the company. But I always love to have this triptych of vision, strategy or strategies, and tactics. Okay, and a lot of people I worked with over the years are a little bit confused about putting the tactics first. Okay, and I really like the idea of having the vision, and we all align to the vision. And based on this vision, then you can define strategies, and based on the strategies, you can define the tactics. So that's I didn't. This talk doesn't talk about the different roles. It was mainly kind of technical roles, but this is something that your product manager or should bring, or even to the portfolio product manager should bring to the table and share with the team, so they align and they share and they have this common vision. This is an excellent comment. I like that. How much security is implemented in the open source cloud? So I don't know what you mean by open source cloud, but a lot of the products that are when you look at some of the cloud offering, and I'm going to pick on the favorite thing I like to pick on, which is Amazon EMR. So EMR is Elastic MapReduce, okay, and so it's a bundle of Apache, Hadoop, Spark. They all combine together, make a distribution, and they call that EMR, and that's available on AWS. They are not current on the versions because they have to have some kind of at least minimum security reviews of what they're going to deploy, as they might be liable, to deploying things that don't work. So in that way, it makes sense to it makes sense to to make sure that the components that or the version of those components that are being deployed on their cloud makes sense. Okay, so and makes sense in the ways that it's that it matches your need on your project. So if you need Spark 3 and EMR is only delivering Spark 245, for example, well, then you're stuck, of course, but you've got to wait and you create a dependency on your project. So Kevin, so how do you propose to keep the documentation up to date? Do you have a user story for someone to update a doc for code being updated concurrently, or do it for the code that was completed in the previous sprint? I see concurrently being difficult as the code may change until the last few days, but what is your experience here? So it depends on what the granularity of your documentation is. Okay, I believe strongly that code documentation should not be outside of the code. That's a personal feeling I have. So when it comes to really documenting code, it should be in the code, and that's part of your code reviews. Okay, so when you've got all this pull request at the end of your sprint, people will just look at the code and say, hey, just add your comments here. Okay, but that's also part of your definition of done. So one very important thing is you've got to align with your Scrum Master about your definition of done. If your definition of done does not include documentation, yeah, you cannot blame anyone. But it's not a different user story. You can imagine at the end of the project, or if you want I was on a project where we decided to phase out or temporarily phased out a project. So we had specific user stories for writing documentation in the context of phasing it down. So we could keep track of what was happening. But this is not, I would say this is not the rule, but the default rule. Okay. For me, documentation is part of the definition of done, but the documentation you're tracking is also the more high-level documentation. It's not your code documentation. Your code documentation is in your code. Yep, comments in the code, as you said, and not a separate design document that you update. Of course. I'm sorry if I misled you there. You've got your architects, okay, and like your enterprise architect or your solutions architect, and those people are responsible for the architecture. And if you see that you find impediments as you develop or during the sprint, then you've got to update your documentation, right? And that's part of the architecture documents. And of course, it's linked to the developers, but it's not. We're not in this gated project anymore. It's not the architect do something and write all this waterfall documentation, and then the developer takes over. Okay, they work in sync. Okay, and on the project I'm on, I've got a great solution architect who's working in sync with the developers and is doing this as the developers go further. Is taking all this intake and making sure that everything is in sync. Yeah, and Swagger, I mentioned a few times payload before, and Swagger is a great tool, or Swagger Hub is a great tool for synchronizing and building and describing payloads together. Okay, I used to love another tool which was called RESTlet Studio, which I think was even better than Swagger Hub, but it's not available anymore. But yeah, typically your Swagger file and more than that's even so the Swagger file can define your payload, can define your endpoints, but it defines a contract that both systems have in a microservice architecture, the consumer and the server. Yep, exactly. Yeah, any other questions? We're almost at the top of the hour, so.
Hi, it's Victor. Can you hear me this time?
Yeah.
Okay, I had too many places I had to unmute. The crux of my question was, you know, we've talked about trends and tools and, you know, technologies and so forth, where we are today. I'm curious if anything stands out in your mind, a couple examples of some technologies or standards or languages or whatever, which at the time appeared that they were headed for, you know, widespread adoption, technical acceptance, et cetera, but in reality sort of petered out within 2 or 3 or 5 years. And if so, any idea why, what might have been lacking there?
Well, I think our industry is full of do's. Okay, one I've got on top of my mind is Ruby on Rails, and you've got to have a critical mass at some point, and if you don't reach this critical mass, then your tool is condemned to be in oblivion at some point. Okay, so that's why I'm also trying, when I pick up tools as part of my EA work, to make sure that it's something that is mature and that is not going to disappear right away. And that's not an easy task. Okay, how do you do that? How do you do that for an open source tool? Because it's open source, so you still have the source code, right? But so it's part of this. But there's plenty of examples. I was picking Ruby on Rails because I had a discussion not long ago with a friend. But there's plenty of things, and there's also false alerts. Okay, I was making fun of a little earlier in this talk about NoSQL. There was this trend at some point where NoSQL is going to take over SQL, okay, on traditional relational database, and everybody thought so. To a point where, you know, oh, the next thing is Mongo, and you had this Mongo stack, and you had, and then you had Elastic, and all those things. So they have their place, and I love a lot of them, but the relational database is not replaced. Okay, so there's a lot of marketing in our industry, and it drives some decisions sometimes which are a little bit crazy, and yeah, we make mistakes. I used another example was a toolkit from Google called GWT. Okay, GWT, Google Web Toolkit. It was a toolkit that Google came to build UI based on Java, and then it would be compiled into JavaScript and run in the browser, and it gave great results until they decided to do Angular, and until Facebook decided to share React and all the bazillion JavaScript frameworks. So, you know, and it was a good idea. And I had a few projects with a good friend of mine, and we had awesome results, awesome user experiences. But you know, we could not. It was not, you know, trend shifted. Tech tip in some way.
Thank you.
Welcome. Okay, I think it's 1:02. So anyone from the select group that want to say something?
Thank you so much, JG, for your time today. And thank you guys for all joining us. Appreciate all the questions. We'll have the recording out to you later on this afternoon. Hope you guys have a great rest of your Tuesday.
Tuesday. Thank you.
Have a good one.
Bye-bye.
Thank you.
Bye. Thank you.